chapter 6, OSPF basics. Okay, basics of dynamic routing protocol named as OSPF, Open Shortest Path First. Okay, so in previous chapter we discussed about static route. Static route means we have to manually configure. Okay, if a remote network is there, means in a router you want to manually add that route with the next hop address or exit interface. Okay, problem with OS the static routing, no, if the network topology changes, we have to change the routes manually. Like we were having one link down, means we have to find another route and manually add in the network. Okay, and again it will be not possible for bigger network. Okay, so bigger topology it's not possible. Okay, dynamic routing protocols means using live networks because of flexibility, reliability, and scalability. So we can add any number of networks easily because they are done dynamically. You don't want to add manually. If any changes happen topology, they will update among the routers in the table automatically. So for that we use one dynamic routing protocol, open shortest path first. Okay, the widely used one. Then we'll discuss this one. Discuss the advantages and classification of dynamic routing protocol, basic OSPF concepts and scenarios, working mechanism of OSPF, implement basic OSPF configurations. Okay. So why we use dynamic routing protocol? See, static routes we manually configure. Okay, we have to manually mention which route you want to add, which network you want to add, which exit interface, what is the next hop. Everything we do manually. Okay, it's applied only to small scale or stable networks. Okay, the number of networks are more, means number of device increases. So the configuring that routes in all routers will be a huge task. Okay, and it is unable to dynamically respond to network changes. Okay, when a network changes, okay, topology changes means it is not updated automatically. We have to manually add the new route to the router. See here, R1, R2, R3. It was the first route was R1 to R2 static route. Okay, but what happened? This route was down. This interface is down, and you have to make another manual route between R1 to R3, R1 to R3 to R2. Manually, you have to configure, not the automatically not done because it is static. Okay, now classification of dynamic routing protocol, interior gateway, we have RFP, OSPF, ISIS, okay, exterior gateway protocol, BGP, by working mechanism and algorithm, distance vector and link state routing protocol, distance vector come inside that we have RIP, link state routing protocol, we have OSPF and ISIS. Okay, maybe they'll ask you, which are the, which one routing protocols coming under interior gateway routing protocol, RIP, OSPF, ISIS. What about exterior, BGP? Okay, border gateway. Distance vector routing protocol, RIP. Link state routing protocol, OSPF and ISIS. Okay. So what is distance vector routing protocol? Here the routes are added by calculating the distance and direction towards the destination. Okay. So here I will find the shortest path to the network, destination network, by calculating the distance and directions. Okay. So distance vector RIP is a distance vector routing protocol. Periodically flood routes. Okay, routes are being added. So each router learns routes from neighboring routers. Okay, each router will be getting details about the routes from neighbors. Okay, install the route in its table. So the router will be clear about destination, where the destination is, and how the destination is far away. Okay, but it's unclear about the whole network topology. That's a problem with distance vector algorithm. Okay, so they know distance and vector, how far is the destination and what is the direction you want to take. Okay, but when you go for link state routing protocol, distance from the, it's different from distance vector routing protocol. Okay, they will be advertising link status information rather than routes. Okay, what they will advertise is link status, whether the link is up or down, what is the bandwidth of the link, what is the cost of that link, all those things will be advertised to other routers, not just routes. So in distance vector, no, what we are updating, we are sending is routing information. No, they are updating route information. Okay, but here main thing is link state advertisements. Yani the state of the link up or down, then what is the bandwidth, what is the cost of the link, everything. Okay. So here routers run a link state routing protocol to establish a neighbor relationship and then exchange link state advertisement. Okay, first we have to establish a relationship, neighbor relationship with the routers, then exchange the link state advertisements. Okay, so what does that link state advertisement contains? Routers interfaces status information. Okay, interface status up or down, cost of the interface, and the interface name. Cost means some values. Okay, I'll show you how to calculate the cost. Okay, so here link state routing protocol, LSDB creation. Okay, each router generates link state advertisements and add that link state advertisements to its link state database. Every router will have a database, link state database. In that they want to add the information generate about each link state from its neighbors. Okay, so here every router is LSDB, LSDB, LSDB. They will get send and receive link state advertisements. There will have the state of the link, its cost, everything. Okay, and link state routing protocol. They will choose. They will use shortest path first algorithm. Okay, so each router uses which algorithm is used in OSPF to calculate the shortest path. Okay, we have shortest path first algorithm, and for that LSDB informations are used to calculate the routes. Okay, so we will find out which one is the least, which one lowest or shortest path by checking the information in link state advertisement or link state database. Okay, each router calculates a loop free tree with itself and shortest path. Okay, so we have to find the path with loop free. Okay, then what is the core algorithm of OSPF? Shortest path first. Okay, so I will tell you the steps. Okay, so how do we generate the routing table? Okay, so here first we want to find the shortest path. Based on that, router will install the routes in the routing table. Okay, we'll see that one by one. Now this one, this is enough. Okay, so how do we generate routes in link state routing protocols? Okay, OSPF. These are the 4 steps. Okay, step 1, step 2, step 3, step 4. Okay, first one, establish neighbor relationship between neighboring routers. Okay, so between routers, no, we have to make a neighbor relationship. First you have to make sure or find out who are all neighbors. Okay, you send some hello packet, when they reply hello, that means they are neighbors. Okay, like that, first find the established neighbor relationship between routers. After that, once you find your neighbors, then only we can send or exchange link status information and synchronize LSDB information between neighbors. Okay, second one is after becoming neighbors, no, I will send my link status information. Okay, so what is the content of my database? Then I will make a link state request. Then they will send me link state update. Then we'll acknowledge. So all the link state informations about each links connected to the other router we will store in the link state database. Okay, third one, calculate optimal path. Based on those links, no, I will find out the best path to reach the destination. Then generate route entry based on the shortest path tree. Then based on that, I will have a shortest path algorithm. No, by using the shortest path algorithm, I found that this is the shortest path to reach the destination, all destinations. Okay. Based on that, I will make route entries in the routing information table, RIB, routing information base. Okay. The first thing, neighbor relationships and hello packet between routers. Then link state updates. We want to make sure the database, that particular table is empty. Then we have to make the link state request. Other router will send update back. Then we will get information about the links. Then we will find the shortest path based on those links. Then we will generate the routing table by adding the routing entry. This is what 4 steps. This is enough. Instead of going through these slides, no, go for this slide. This is enough. Okay, 4 steps. Now, what about OSPF? As I told you, OSPF is the best link state routing protocol. Okay, then it exchanges link states information, not routes. They are exchanging the information about the link state or status. Okay, the router collects link states information network and stores in where they will store in. They will store in link state database. Okay, then each router uses shortest path first algorithm to calculate shortest path. Okay, first of all, we will make neighbor table. neighbor relationship, then we go for link state database table, all the state of the links, then we go for shortest path algorithm to find the shortest best path to reach the destination, then we will make the routes out of this and store in routing table. Okay, and we use here routing summarization is not supported automatically, we have to do manually. Okay, it supports VLSM. Then how do we apply OSPF in a campus network? See here, core switch, aggregation switch. So we will have core switch and aggregate sections will run OSPF to implement reachable routes. Okay, so OSPF is implemented on core switch and aggregation switch. Okay, to implement communication between different networks. Okay, different devices, different level. Then basic OSPF concepts area. So area means a domain where OSPF routers are connected. So this is a logical group. So in this group or in this domain, we have three routers. How to identify this particular domain? We give them an area number, say area 0. This is their identification. They belong to the same group and the group is called as area, have a number 0. Then how do we configure? Okay, basic OSPF concepts actually, not the configuration, concepts. Okay, router ID. Every router identified in this area 0 will have an identification. That's why we use router ID 111 for R1, router ID 222 for R2, ID 333 for R3. Okay, so identify each router in a area. We need unique identification. For that we use router ID. Either manually we can add or we can automatically assign. Okay, by system. And then basic OSPF concepts again. Now, how do we calculate the cost of each interface? We told you the link state or the status of link. It depends. It contains this cost of each link. Okay, so calculate the cost of link. We have the formula default cost value equal to 100 Mbps megabits per second by interface bandwidth. Okay, this 100 is reference bandwidth we have to use in OSPF. Okay, so here see serial interface means the cost is 64. How, Mr. You got the serial interface cost 64? I will show you that formula. Okay, I already done this. Okay, so formula is, see, default cost value equal to 100 Mbps by interface bandwidth. Already the bandwidth of serial interface they give 1.544 Mbps. Now I know 100 is the default reference value. How do I get the cost 64? I'll show you the formula calculation. Okay, 100 reference bandwidth divided by 1.55, sorry, 1.544. Now what I am going to get 64.7 rounded to 64. Now this is serial interface. Now fast Ethernet interface, how we get cost one is the fast Ethernet interface, the default interface bandwidth is 100. So 100 by 100. See this fast Ethernet now their interface bandwidth is 100. So what I will do 100 Mbps, which are the default preference, divided by 100 the cost of fast interface. So it will be 1. Sorry, interface bandwidth of FE. That's why 100 by 101. Giga also I put the same. Okay, this is how we take the cost of interfaces. Okay, now accumulated cost on OSPF path. See, from R3 to this network, what is the cost of the total cost, or accumulated means total cost of the path. Okay, so here I got 64 in this link for this link. Okay, here from this R2 to R1 I have cost one. Say R4, R3 to R2 this is cost 64, R2 to R1 cost 1, R1 to network 10. So total cost from link cost from R3 to 1110/24 is 64 plus 1 plus 10. That's why it is 75. Okay, the cost of OSP route from OSPF route from R3 to this one is 64 plus 1 plus 10. Okay, done. Then different types of packets are there in OSPF. Okay, first one, hello. I told you first step in OSPF communication is make what? Neighborship. Okay, neighbor. We have to find who is my neighbor. Router has to find who is the neighbor who is going to send me the link state advertisement. So first thing to find the neighbors, no, I want to broadcast or I want to send hello packets to discover who is my neighbor. I'm going to somewhere. No, I want to check who is there. No, what I do, I should do say hello, hello. Are you there? Anyone there? Like that. Okay. Even in discover that DHCP also we have discovery message. No, there also we are finding out where is the DHCP server. Here, each OSPF router trying to find out who is the next OSPF router existing there. That's why we use hello packet. Next packet is database description (DBD). Here, this packet is used to synchronize the link state database of two devices and to make sure both routers link state database table is synchronized, whether it is empty or what we are synchronizing that. Okay. After that, link state request. If a router wants to get the information about the links, he has to send link state request or link state advertisements. Okay. It has been done only after DD. First, hello, neighbor you have to find. Then DD, make sure that the link state database are empty or synchronized. Then we have to send link state advertisement or request. I want to details about the link state of the link. Okay. Then the router will advertise the update about the link state. Then acknowledgement. This is what hello DD LSR LSU link state. Okay. Then three types of OSPF entries. How do we find the entries in neighbor table? Okay. See, this go to R1. See, R1, R2 are connected. R1 has router ID 111, R2 has 222, R1 has G100, IP address is 1011/30, R2 has G100, 1011/30. And I type the command display OSPF peer. It will give you details about your neighbor. Okay. See, OSPF process ID is 1, router ID is my router ID is 1, my neighbor is see 222, my neighbor router ID 222. This is my neighbor now 222. Address is 10112. Yes. Then state full, adjacency is full. Okay. Priority, master priority is 1. Who is the master? This one because that's ID number. Okay. Then designated router BDR. Among these two, which one is designated router? What is DR? BDR? I'll tell you later. Okay. So neighborship is on for 05 from 05 this time onwards. Neighborship is there. That means they are neighbors. So how to find out the neighbors? Can check display OSPF neighbor. If you could see the neighbor ID, router ID here, that means this ID, so whoever router has this ID, he is the neighbor of R1. So 222 is given to R2. So R2 is R1's neighbor. Okay, that is done. Now three type of OSPF entries in the LSDB table. This was which table? Neighbor table. First I told you neighbor, then go for link state database. Okay, so here LSD table. Further the command is display OSPF LSDB. So here router. Okay, R1 we have three different types of okay LSDB detail. Router, who is a router here? Its ID 222. Then ADB router. It means the advertising. Who is advertising? That one 222 is advertising, right? This ID. Okay. Then age, that all not important. Okay. Then another one is router 111. Okay. So the same router, its ID 111 advertised by same 111. Okay. Network. Then we have in between we have a network 10112. Okay. This is a link state of that which one router which is connected to 1011, that one network 0. Who is advertising this 10112? This 222. Okay, this is what advertising which one router type indicates the type of link state advertisement. Okay, router advertisement, router and then network advertisement. Okay, it's mentioned over there. Then we have OSPF routing table, display OSPF routing. Now this is like show IP routing. We have display OSPF routing. The R1 has process ID 1, router ID 111, and the routing table has three entries here 1111/32. Okay, it is my own network, cost is 0. Next hop, I don't want to go anywhere, it's my same one. Then advertise and router, I'm advertising. Then next one 10110, this network, cost one link. Okay, the cost is 1. Then 10111, my next hop with this one. Reach here, I can go with this one. Okay, Then advertising out, who is advertising 111. Now next one is 222. This network. Cost 1. I have to go here to the link, right? The cost is 1. Then next hop, who is giving that one? 10, 112. Next one in this one. Advertise not, who is advertising saying 222. This. Okay. Total network 3, intra area 3, inter area 0. Because it is between same, no? It's not outside this way. Then OSPF working mechanism. So here we have a concept like the D, LSR, LSU, LSAK, whatever we discuss, same thing here. Okay. How do we establish adjacency? We have to first send the hello packet. Okay. Then we establish a bidash and neighbor relationship. Okay. By sending hello, we can establish the neighborhood. Okay. Then make them find out master and slave. Who will be the master? Then who will be the slave? Then describe the LSDB. The what about the description for database, whether it's empty or not, or synchronize that one. Then we have updating LSA. Okay. So make the link state request, then update and acknowledge, and LSDP will be done. So links to database is done. Based on that, find the shortest path and add the routes to the routing table. Okay, that's what 1, 2, 3, 4, 4, 5. Okay. See adjacency, hello packets are sent. Hello, I am 111. R1 is sending hello packet. I am 111. I don't know who is this. Then R2 will send back hello packet. I am 222. I am from number. Then hello packet. I am 111. I found my neighbor. Now these three messages will make sure that they become neighbors. Okay. Generally, we can go for which one? Because for DD and LSDB, right? Now DD database description, right? So for that, first this empty. I am the master of my router is 111. Also, we also will send empty. I am the master. My router is 222. So what happens? This will become the master node. Okay. So because router ID 222. Now DD they will send sequence number and these people will keep on sending what link state advertisements. Okay. Once you get the link state advertisements, now based on that they can make their link state database. Okay. So database description means so for synchronization, just for synchronization, the link state database table. Okay, LSDB table mentioned over there. Then now adjacent to step 4. Now after making that DD, no, they are going to make the link state request. So I am requesting LSA from the other router. They will send update, then they will accept it. Then again he will send back the link state request. So this is how we get the link state updates or advertisements or messages. Okay, sorry. Then neighboring table, when we have R1, R2, R1 is 111 router ID, R2 is 222, R1's neighbor is R2, R2's neighbor is R1. How do we discuss? How do we check the neighbor table? Display OSPF peer command in R1, like show IP route. So process ID 1, router ID 111. So this is okay. Area is 00. Okay, interface is 1011. Giga 100 IP. Neighbors R1 discovers a neighbor in area 0 and G1 G100. Okay. So the router ID of neighbor. So my neighbor is R2, its router ID is 222, address is 10112. Okay. State is full. Now they form neighborship. That's very full. Neighbor is the master because the priority is 1. Whoever has the priority 1, that they will become master. Okay. DR and BDR. DR means designated router. BDR means 10 backup designated router. So what is DR? Designated router means, see here the routers keep on sending updates. Okay, every router has to send updates, from neighborship. They will keep on sending LSA requests. All routers will send here to every other router. So what happens because of that? No, the routing table will be more data. They will be generating more traffic in the network. So what I will do? I'll choose one router as designated router. Another one will become BDR. They only update those information instead of updating all routers, updating information other routers. Now only updating them only by BDR and DR. Okay, mentioned over there. Network types: broadcast, NBMA, P2MP, P2P. So Broadcast means here. So before that, what is that? Point to point. Okay. These routers are connected by point to point cable, serial cable. Okay, and it is PPP link. Then broadcast multiplexers means see R1 is going to broadcast a message to both other routers. Okay, broadcast multiple device to access and support broadcast. Okay, Ethernet network is a broadcast network. Then broadcast the packets. Okay, now this is non-broadcast multiplexers. So multiple network device to access but does not support broadcast. So remember these names. Frame relay is the typical non-broadcast multiplexers network. And here BMA, default network type of OSPF is BMA. Okay, so which one is the default OSPF network type? They will say BMA, broadcast multiplex. Okay, so for P2P, the default network type of PP OSPF is P2P. Interface is P2P. Okay, for PPP calculation. Okay, point to point encapsulation, the network default network type is P2P. But for interface with Ethernet encapsulation, they use broadcast multiplexers. Okay, remember for point to point or serial cable, the encapsulation, the network type is default is P2P. For Ethernet, see GE00 or FE00, the network type is BMA. Then non-broadcast multiplexers, multiple network devices access but does not support broadcast. Okay, so multiple device can access network but they will not broadcast. Okay, example is frame relay. Okay, then point to multi-point, bundling endpoints of multiple P2P link. Okay, multiple P2P link is enough. They will combine into a single P2MP network. Okay, so this one written there. Now background of DR and BDR. Okay, so usually in the multi-access networks. Okay, what is that multi-access? BMA and NBM. What is BMA? Broadcast multiplexers and non-broadcast multiplex networks. Now the routers will form adjacency with other router, every other router. Okay, every router will keep on sending hello messages. They will keep on sending DBD messages, link state requests, everything. What happened? The router will get loaded with more packets. So what I will do, instead of every router sending neighboring updates or hello packets or link state requests, now what I will do, I will choose one router as designated router, another one BDR. All the updates will be sent by these two, and these other routers will become called as DR other. Okay. Now, how do we choose one switch as one router as designated router, another one as backup designated router, and others are DR other. Okay. Interface with higher priority becomes DR. Whichever interface has higher priority, they will become DR. Priority default value is 1. If all the interface priority for the routers are same, the router whose ID is higher will be chosen as DR. Okay, I'll show you examples. Okay, I think we have that examples. We'll see that later. Okay, now OSPF domain and single area. Domain means area where a group of OSPF routers connected together. Area 0 means all these. Okay, so what happens now here? Area 0 means all the routers, OSPF routers belong to same area. They are in the same domain. So what is the advantage? What's the disadvantage is if number of routers increase, no, the link state database also will be increased. So routing table entry will be increased. Now what happened? Resource will be more used and difficult to find out the shortest path network or table, shortest path. Okay. Then multi-area OSPF means my routers are divided into multiple area. So there is not broadcasting will be limited. Resource utilization will be limited. Like you have difference between broadcasting switch and router. No switches. No more number of devices connected means more number of frames will be flooded. So okay, it will be more huge. So what I will do, I'll make a router. Okay, it will divide broadcast. Same here. We have same area means all the routers, every table, everything will be too high. So traffic will be more. When we divide this into multiple area, the broadcasting also limited. The load for the router also limited. Okay. Different types of areas. Backbone area, non-backbone area. Area 0 means backbone area. See, this is backbone area. All other areas are non-backbone area. So I'll ask you, what is the which one is the backbone area? So remember, area 0 means backbone. Any other area like 1, 2, 3, 100,000, whatever it will be backbone area. Multi-area, see all areas except area 0 called non-backbone area. Multi-area interconnection means to prevent inter-area loop, non-backbone areas cannot be directed on each other. Okay, all non-backbone areas must be connected to backbone area. Okay, see area 1, area 2 are non-backbone. They cannot connect themselves. Okay, directly. They have to get the help of backbone. Sorry, they have to get the help of area 0. Okay, that's multi-area connection. Then we have different types of OSPF router: internal router, area border router, backbone router, AS boundary router. Okay, internal router means, see this one, IR. All interface on internal router belong to same OSPF. Okay, so whatever interface we have in this router belong to area 1. No other interface is connected to another area. Okay, ABR, area border router. Interface of ABR belong to 2 or more areas. See, this router has interface, one inside this side, one other side. Okay, one, but at least one interface belong to backbone. So here one bond is belong to backbone. Okay, then backbone router means at least one interface of backbone router belongs to backbone area. Okay, backbone router, this one. Okay, here one interface is connected to backbone area. Yes, one is connected to backbone area. Okay, ABSR, exchange routing information other ASS. Okay, autonomous system. So here this is one which will exchange information other autonomous system routers. Okay, small and small or the typical OSPF single area multi area. Okay, so OSPF 0, all the routers or devices are connected to single area, small and medium sized network. Multiple area means, see, some are in OSPF 0, some are in OSPF and some are in OSPF 2. What happen, big company means more traffic, more packets. Okay, now OSPF configuration is easy. How do we configure the OSPF? First, you have to write, go to system view, right? OSPF process ID, router ID, right? Then create an area ID. Then specify interface that run OSPF. So first thing, set the cost of OSPF interface, OSPF cost. Then cost will be from 1 to 65,535. Then we have to set the bandwidth reference value. 100 is always used. Okay. Then priority, OSPF DR priority. We choose that. So priority. How do we choose the DR? No, the interface priority, right? So OSPF DR priority, it will be from 0 to 255. Bandwidth reference, see, 12215 this Mbps. So the default is 100 Mbps. Okay. Then how do we configure example? See, I have three routers R1, R2, R3, R1, R2, R3. They have, say, R1 has loopback IP 111, R2 has 133. R1 has two interface, one network connected here, we are also connected. R2 has this and this two network connected, R3 has this. Okay. First you have to configure the interfaces, then configure OSPF, then verify result. Okay. How do we configure the interface? Okay. Go to R1, enter loop, this is loopback 0, LO0, give the IP address, then give G0 bar 0, the IP address. R3 also same. First loopback IP, then go to the interface name G0 bar 01, then IP address. So like that R2 will do. Here. Then configuring OSPF now. See, how do we configure OSPF in router R1? Go to R1 OSPF 1 router ID. So OSPF 1, this means this one is process ID. Then router ID, ID of this router. Then area 0, we want to say network backbone area 0. Okay. And what is that value? Network 4140. So here R1, whatever networks we know that you want to add. Okay. So R1 knows 1111 is one network. Okay. Area 0, 111, and this is wildcard mask. Okay. That means 255, 255, 255, 25. All the values should be same. Let's say 255. Wildcard mask means subnet mask is 2554 means wildcard will be 40. Now next another one network they add. Okay, router area. This one, where is that network 10.11, 10.1.12.0. This one, this network. Slash 30 means 255, 255. So what is slash? Why Mr. You put 03 means? I'll show you. So what was it? Okay, 003, right? So actually slash 30 means 2 255 dot 255 dot 252 dot, sorry, I'll write here the word, okay, better. Slash 30 slash 30 means 255 dot 255 dot 255 dot 252. Wildcard means all the network becomes 00 becomes 1, okay. Okay. So for what happens if we need wildcard mask is a opposite of subnet mask, okay. So 255 means full one, no? So here it will be 0. Again 255 full one, here it is 0. Again 255 full one, here it will be 0. Dot 252. Remaining how much? 3. So this will be 3. Like this you have to make the wildcard mask, okay? Done. Now how to configure OSPF2 in R2. R2 I have to mention root ID. Here also mention root ID. No? Yes. So our OSPF1 router ID area is 0. Yes. Network is 10.1.1.12.0 slash, okay, slash 30 means it will be dot 3. Area 1 we have another network. Network is 10.1.23.0. Now R3 only one area R1. Area 1 we configure this thing. Okay. This is how we configure the which one? OSPF. And now how do we display the OSPF neighbor table? Display OSPF peer brief. You can see area ID, their neighbor, everything will come. Okay, this is what coming under what OSPF chapter. Okay, hope you understood. So I'll stop this.